Hello! In this video, we're going to complete one of the last big pieces missing in terms of developing A-frame applications in your WebXR applications in general, and that is creating custom events. So we've seen so far that everything we've created has been based off of click events, right? We click on the cylinder and we turn it red. We click on this cube and we add spheres to it. We click on the sphere up here and it triggers an animation. So now what we're going to do is make our own events so that we can essentially have different objects communicate among each other. And this will add even more interactivity into the scene in terms of making it feel like what you're doing is not these preset functionalities like moving this object in the same direction every single time. What if instead of the sphere moving off in the distance, it actually moved to the location of other objects we clicked on? And so that's what we're going to do when we make our custom event. So let's get started. So we're back on our index.html. And actually, the first thing we're going to do is make a new script. So this one we're going to call return emitter to kind of fulfill exactly what we just said it's going to do. It's going to any object that gets clicked on is going to emit an event that causes the sphere to return to that specific object. And so following the syntax that we have for making components, we're going to do a frame.register component. We're going to call this component return emitter. And then we're going to add this JavaScript object in here. And so we're going to have our init function. And we're going to do our usual process of capturing the entity itself here. And we're going to add in a relatively short function, actually. This one, we're going to say this.return call equals function. And from here, we're going to say let p equal el.getAttribute position. And so we'll grab the position of the current entity, whichever it is. And the next thing we'll do is el.emit. And so this is a JavaScript just web-based function. This is how events are created. So we have a reference to the entity, which is just an HTML element, and we can do .emit on it to create an event. And so in here, what we'll do is the first thing was we'll pass in the name of the event. So, much like there's a click event, we're going to make a return sphere event, where it's going to specifically reference the sphere in this case. And the next thing we're going to do is we're going to pass in, like we saw with the target marker, where it comes with these event details. We're going to pass in an object for the event details. In this case, it's just going to be an object with a single property, which we're going to call return point. And that's going to be P, which is the position that we just captured for the current object entity. And so then after this, we will do or this.el. It actually doesn't matter either way because we already have a reference to that, but we'll just kind of follow that convention. And we'll still be listening for click events in this case, but it's going to be this object listening for click events, and then it's going to broadcast an event for some other object for it to communicate with that. So we'll have a click event, and then we will have this function called return call that we just defined. That'll be what actually happens. And then the last thing that we do with every single one of these components, just for good practice, is we do our this.el.remove event listener. Just to be practicing good standards here, and we'll remove the event listener that listens for click events and does the return call. And so this is actually everything we need to define for this component. This is everything for the component that's emitting the event. It's actually quite straightforward. You could, of course, have more details in here if you wanted to, but otherwise, this is all it takes to emit an event. Most of it's just kind of the same boilerplate that we've seen before. So what we have to do next is actually we're going to modify our mover.js code a little bit. So we have this animate move component here. Or this animate move function rather, and we're going to make a new function called return move. And so we'll have that, and we're actually going to capture the event details of this one. Again, much like we did with the target marker, and we'll just call that E. And in this case, we know that we defined our own event details here, so we can say let p for the position that we want to go to, and we'll do e.detail.returnPoint. as our only property that we have there, so that if we hear this event, we can capture the detail and we'll get the position that was passed through. And so we're actually going to do something very similar to what we did with our last animation component. So we're actually going to grab all of this code, and we're going to do a little code duplication here. There's definitely better ways of doing this formatting wise. But we're basically going to do something very similar to the last one. But instead of current position, right, this time we have this p value that we want to use. And for our 2 value. And so we don't want to have it be 5 off in the distance. Let's have it go to the position of the current entity, the current object that did the broadcast. But let's have it be a little bit above. So we'll add 2 to the y value, so it's a little bit above it. And just for the sake of making it a little interesting, let's change this from ease in out elastic to ease in out quad, which is just another easing function. And then otherwise, it's the same thing. We set the attribute, the animation component to the parameters that we have defined here using this p-value. And so that's all set up. And so the last thing to talk about here is that the way that events get emitted is that they bubble up through the hierarchy. So while we're looking at this, we'll include the script here, source equals, and then return emitter.js. And let's say that we want to have it return to like the center of the plane. So we can put the return emitter component on here. And we have our mover component already on the sphere. But at the moment, we'll go back to our mover and just really quick add in the event listener. So let's say we add the event listener to our entity. And we're listening for the return sphere event, right? And when it happens, we want to do this dot return move. And likewise, in the remove function, we'll just kind of move that over and change add out for remove there. And remove that event listener for the return sphere event that's being produced. And we can come back to the file here, and when we click on the sphere, it still does its little wobble and moves off in the distance, right? Because we still have that click event that we're listening for on it. It just has another event listener on it as well. And so we have this click event that we're listening for on the plane, but when we click on it right now, nothing happens. And that's because when an event is created from another object in the scene, the event bubbles up through the hierarchy. And so because the sphere and the plane are on the same level of the hierarchy, when the event gets created, the sphere, the listener on it, never hears that event because the plane is here and the sphere is here. They're both at the same level. So when the plane creates that event, the plane itself can hear the event, and anything higher in the hierarchy can also hear it. And one of those things is the scene. So what you can actually do is that instead of putting the event listener on the sphere, you can attach it to the scene instead. And to do that, we need to actually capture the scene and use the scene element. And so one thing we didn't cover before, but you actually have a reference to, is that instead of doing a query selector, you can also, every element in A-frame has a reference to the scene element. And the way we access that is this.el.sceneEl. So we can just add this in here, and likewise in the remove event listener. And so now we're adding this event listener to the scene as opposed to the specific object this component is on. But it's still being applied to this component. It's just the listener is in a different place in the hierarchy where it can actually hear the event go off. And so now we can go back to our application and we can have this sphere move off into the distance, just to give it some distance away. And now if we click on the plane, we see that the sphere actually travels to the center of the plane. And likewise, we can have it move away again, but it's still doing the event listening. So like any stage in the animation, if you click on the plane again, it'll change the animation component and it'll return back to the center of the plane. And you'll see I'm moving around here just so that the cursor that I have here isn't firing these raycast events off in the center of the screen. And the really cool part about this is that now we have the sphere that will go anywhere we click on as long as that object has this return emitter component on it. So the plane has a return emitter component on it. We could then add a return emitter component to the cylinder, and we can just add it to the box as well if we want to. We can just add it to all the objects in the scene if we want to. And this is probably one of the most interesting places where you see this component get reused, because we can have the sphere go off in the distance. We could click on this plane, it'll move to there, or once we click on the cube, it'll change paths and come to the cube instead. Or it can go over to the cylinder. It can go anywhere that we have the return emitter component on. And you can customize this, right? So you can change the parameters in your return emitter, or in your mover rather. You could potentially do some calculation of the distance between the point that the sphere is currently at and the point that we've received through our event, and based on that distance, change the duration of the animation so that maybe it always moves at that same speed regardless of where it's going, right? Because at the moment, if there's an object further away, it's going to move much faster to get there because it always has to get there in 5 seconds. So that's you have the basis here for an immense amount of different functionality you could integrate into this, and an immense amount of interactivity that you can include just from basically clicking on things and looking at things. And if you wanted to go to this URL on your phone, you could enter VR mode on your phone or on a VR headset you already have. And then just look around the scene, and when you look at something, I look at this plane for 3 seconds, and it triggers that raycast event, and then the sphere goes there. So you can have this be entirely, no input required besides gazing around. Extremely powerful. And so that's the last major topic we're going to cover for now, is the idea of creating custom events like this as a way for different entities to communicate in the scene. Just remember that there's, adding the event listener to the scene element is just one way of having to communicate, but it's an extremely simple way of doing it. And having this communication happen and share this data, and then you can have much more, you can have it as dynamic as you want for these animation components, and as much complexity as you want in it.